A healthcare agency wants to determine whether the age of residents in nursing care in New York City is less than 85. If it is, then it would develop some new programs for senior care. A random sample of 30 patients give an average age of 87 years and standard deviation of 8 years. What should the healthcare agency conclude?
We start with formulating the hypothesis. In this case, the healthcare agency wants to know whether the average age of the residents is less than 85. That is, whether mu is less than 85. This would be our HA, the research hypothesis, and the null hypothesis, HO, would be the opposite, which is mu is greater than or equals 85. We are testing at the level of significance 0.05. Because we are working with the sample standard deviation S, we will use the t distribution and work with the t tables. For one population mean, the degrees of freedom are given by the sample size minus 1. In step 4, we compute the p-value. To compute the p-value, we need two pieces of information. One is the sign in HA, which tells us whether it's a lower tail test, upper tail test, or whether it's a two-tail test. And the second piece of information that we need is the value of the test statistic in step number 3. Then you start by marking the test statistic on the t distribution. The t is positive 1.37, so it will be to the right of the center. This t-score of 1.37 divides the area under the curve in two parts. One is the upper tail area, or the area to the right of 1.37, and the lower tail area, or the area under the curve to the left of 1.37. The lesser than sign in HA indicates it's a lower tail test. If it was the greater than sign, it would be an upper tail test. And if it were an inequality sign, it would be a two-tail test. And we always look for the sign in HA to determine whether it's a lower tail, upper tail, or two-tail. So in this case, this is a lower tail test, and the p-value is given by the area under the curve to the left of 1.37. The t-tables would give us the upper tail area corresponding to 1.37, which is the non-shaded region. We get that area from the t-table and subtract that from 1 to get the area of the shaded region, or the lower tail area, which would be the p-value. In the t-table, we look for the row with degrees of freedom 29, locate the approximate position for the t-score of positive 1.37, and the upper tail area corresponding to this t-score of 1.37 would be somewhere between 0.05 and 0.1. Even though we may not have the exact upper tail area, simply knowing the range within which this value falls should help us reach our conclusion. The upper tail area corresponding to the t-score of positive 1.37 for degrees of freedom 29 is between 0.05 and 0.1. And the shaded region, or the p-value, which is given by the lower tail area, is given by 1 minus the upper tail area, which would be between 0.9 and 0.95. Once we have our p-value, we then compare our p-value with alpha. Our p-value is between 0.9 and 0.95. 0.95. Alpha is 0.05. We notice p-value is greater than alpha, and so we apply the rejection rule, which states that whenever the p-value is greater than alpha, we do not reject HO. When we do not reject HO, we cannot conclude that the HA is true. So in this case, based on the data collected from a sample of 30 residents, the healthcare agency cannot conclude that the average age of residents is less than 85 years.